Hello everyone, welcome to the control system course. This is Amdoor from the Amdoor Educational Academy. In this video, I am going to discuss how to find the transfer function from the signal flow graph. I think you know very well about the signal flow graph representation. To determine the transfer function from the signal flow graph, you require the basic definitions: source node, sink node, forward path, feedback path, and forward path gain, and feedback path gain, and self loop, and two non-touching loops, three non-touching loops. So I think already I explained all this in previous videos. So now in this video, just I'm going to discuss how to determine the transfer function from the Mason's gain formula. First of all, I will explain the step-by-step analysis. Later, I will explain simple shortcut technique to write the transfer function from the signal flow graph directly. So first of all, please go through the this signal flow graph. So to determine the transfer function from the signal flow graph, Mason's gain formula is used. So the Mason's gain formula explains MGF. I'm writing now Mason's gain formula. The formula explains summation n is from 1 to k Pn into delta n. This is delta here by delta. This one is a standard formula, right? So here what is k? K is a number of forward paths. First of all, we have to identify that. So now I'm writing here k. K explains the number of forward paths. See, first of all, I will explain the step-by-step analysis because you have to understand clearly what is the importance of the Mason's gain formula and how to find out each parameter from the signal flow graph. That purpose we require the step-by-step analysis, and this is useful for your semester exams also. So in semester exams, you have to write the complete step-by-step. So first of all, write k. K is a number of forward paths. So the path from the input side to output side is called a forward path. So now for that purpose, we have to identify the input and output of the system. So here the input of the system is R of S and output of the system is C of S. And you have to remember one more important point. This transfer function formula is applicable for single input and single output system. If the system has only one input and one output, then we have to apply this. If the system has more than the one inputs and more than the one outputs, then we have to consider only one output at a time. One output should be active and one input should be active. So at a time we have to take only one input and one output from the multiple input and multiple output system. That part I will explain in next videos. First of all, here I will explain this is considered a single input and single output only. So one input is there and one output is there. C of S always explains the output of the system and R of S explains the input of the system. So we have to identify the number of forward paths from the input to output. So just go through this diagram. Here input side to output side, it has one forward path. Just I want to draw the dotted lines. All of you observe this one. This is comes under one forward path. Let us assume this one is the first forward path because I want to give the numbers, and similarly just identify the path from the input to the output side. Any other path is there? So here this is comes under repetition. If any node repeats, don't take that path. So we have to take the path without any repetition of the node. So that's why I am taking one more path should be like this. Just to follow the arrow mark directions. Based on the arrow mark direction, just identify the exact path from the input to output. So now it has totally how many forward paths? 2 forward paths. So now write the k is equal to 2. So after finding the number of forward path, immediately we have to write the formula. So just substitute k is equal to 2 within this. So Mason's gain formula explains the transfer function from the signal flow graph. So I wrote here TF. TF is nothing but transfer function. So substitute k is equal to 2 within this. Then expand that, then which gives the P1 into delta 1 plus P2 into delta 2 by delta. See, I wrote directly the formula. So to find the transfer function from this given signal flow graph, this formula is required. Now in this here we have to find out P1 delta 1, P2 delta 2 and delta individually. First of all, I am writing P1 here. So what is P1? Generally Pk explains the kth forward path gain. Kth forward path gain. If k is 1, first forward path gain. Let us take k is 2, second forward path gain. So forward path gain, how to determine the forward path gain? The product of individual gains of that forward path. So whatever the path is there, So within that forward path, just we have to find out the individual gains product only. So first of all, I want to write P1, first forward path gain. So this arrow mark explains the gain of the system. So gain of the path. Now within this, just to find the product of the path gain. So 1 into 1 into 1 into 1. So finally which gives the 1 into 1 into 1 into and 1 is there. So P1 should be 1 only. And similarly write P2. P2 is explains the second forward path gain. Second forward path is this path. Just write the product of the gains of that forward path. So 1 into d into 1. So which gives the 1 into d into 1. This is equal to d. So finally we got these two, P1 and P2. And later we have to determine the delta, delta 1, delta 2. To determine the delta, delta 1, delta 2, we required the individual loops, 2 non-touching loops, 3 non-touching loops that based on the given signal flow graph. First of all, draw the individual loops. Here, I am assuming this is acts as a one loop. Loop is nothing but complete closed path. One path starts at one node, again ends at the same node, then it is called a loop. So this is acts as a loop. Now this loop is a self loop because it has only one node, starting node and ending node. It has only one node. That node acts as a starting node and ending node. That's why this is called a self loop. So what is the gain of this one? Minus C. Let us assume this is loop 1. This loop 1 gain is minus C. And similarly, one more loop is defined here. This loop gain is minus B. Let us take loop 2 gain is a minus B. And another loop is defined here, the complete closed path. This loop, so this gain is minus C. Now I am writing the name of this loop is L3 and the gain of this one is minus C. So totally it has 3 individual loops. Don't take this loop because this is comes under forward path. Just you have to follow the arrow mark direction. If the arrow mark is defined in this direction, then we can take it as a one loop. But here arrow mark is defined toward the output side, so this is not comes under the loop path. So only 3 individual loops are there, L1, L2, L3. And from that, just I want to find out 2 non-touching loop pairs. 2 non-touching loop pairs. So what is the meaning of the 2 non-touching loop pairs? If the 2 loops does not have the same node, then it is called a 2 non-touching loop pairs. Then go through the first loop and second loop. Let us write here L1 and L2. For easy understanding purpose, I am writing the names here. L1 loop and L2 loop. L1 loop is defined here and L2 loop is defined here. There is no common node for these 2 loops. So L1 loop, L2 loop does not have the common node. That's why I am writing one pair is a L1, L2. L1, L2 or acts as a 2 non-touching loops. So write that pair now. And similarly, L1 and L3. L1 is defined at this node and L3 is defined here. These two does not consist of a common node. So this is also comes under one pair, 2 non-touching loop pair. So L1, L3. And later compare with L2 now. So L2 and L3. L2 consists only this node and L3 consists only this node. So these two does not have the common node. That's why we can write this is also acts as one 2 non-touching loop pair L2 and L3. So later L3, L1 already I wrote. So L1, L3, L1, L2 and L2, L3. Totally this given signal flow graph consists of 3 pairs. Each pair is a combination of 2 loops. So that's why I wrote 2 non-touching loop pairs. Similarly, we have to find out 3 non-touching loop pairs. 3 non-touching loop pairs here. So now we have to compare 3 loops at a time. If the 3 loops does not have the common node, then the combination is called 3 non-touching loop pairs. Now go through the 3 loops L1, L2, L3. These 3 loops does not have any common node. So we can take this complete L1, L2 and L3 are acts as 3 non-touching loop pairs. So finally I wrote 2 non-touching loop pairs and 3 non-touching loop pairs. Later we have to determine the 4 non-touching. So 4 is not required because the available loops are only 3 loops, right? Then finally just I want to substitute the given analysis complete formula in this transfer function formula. Just go through this one. P1 is 1 is there. So substitute in this and delta 1. I will explain how to write the delta 1. P2 value is D and again I will explain delta 2. Delta 2 also I will explain this one and finally we have to write a delta. So how to write the delta formula? Delta formula explains 1 minus. So individual loops, sum of individual loop gains. So individual loops are here L1 plus L2 plus L3 plus sum of two non-touching loop pairs. Sum of two non-touching loop pairs. Here it has totally three pairs. Write those pairs now. L1 L2 plus L1 L3 plus L2 L3 minus sum of three non-touching loop pairs. So you have to write the formula directly here. 1 minus sum of individual loop gains plus sum of two non-touching loop pair gains and minus sum of three non-touching loops plus the sum of four non-touching loops. Just you have to write alternate symbols, alternate sign changes. So here it has the three non-touching loop pairs. So L1, L2, L3. That part I am writing now. L1, L2, L3. So finally I wrote the formula. Now we have to determine what is delta 1 and what is delta 2. So let us write here. This is delta 1 and this is delta 2. Delta 1 and delta 2 also explains the delta of that forward path. Delta formula is the same formula. We have to apply the same formula here. 1 minus sum of individual loop gains, but we have to take those loops are non-touching of that forward path. So here I want delta 1, first forward path delta. To determine the first forward path delta, we have to find out non-touching loops of the first forward path. So now go through this one. This one is the first forward path. So first loop is touching here. So one common node is defined here. Second loop also touching and third loop also touching. So there is no non-touching loops of the first forward path. So just apply the delta formula. The delta formula explains 1 minus sum of individual loop gains. Here which loops we have to take? The non-touching loops of the first forward path. So all loops are touching loops. That's why I'm writing here 1 minus non-touching loops of the first forward paths are 0. So I'm writing 0. So write as a 1. Similarly, delta 2. So delta 2 explains 1 minus non-touching loops of second forward path. Just go through the second forward path. This one is the second forward path, right? First loop is touching here and third loop is touching here, but the second loop and the second forward path does not have the common node. Second forward path touches this node and this node only, but second loop is defined at this node. So these two are comes under non-touching. So non-touching loop of second forward path is L2. So we have to write here L2. So this is delta 2. Then substitute all this within this formula, then you will get the complete transfer function. First of all, I'm writing P1 is 1 and delta 1 is also 1. So 1 into 1 plus P2 is D and delta 2 is 1 minus L2. What is the gain of the L2? Minus B. Substitute here. Then becomes a plus B divided by 1 minus, right, individual loop gains L1 plus L2 plus L3. Each gain has a negative gain, so minus A minus B. So minus into minus it becomes plus A plus B plus C plus two non-touching loop gains L1 L2 product of these two and L1 L3 product of L1 gain and L3 gain and product of L2 and L3 gain. So minus into minus plus that's what I'm writing here AB plus BC plus AC plus, again the symbol is minus is there, L1 into L2 into L3. So L1 into L2 into L3. L1 loop gain is minus A and L2 loop gain is minus B and L3 loop gain is minus C. So minus into minus into minus is minus and again it becomes here plus. So A, B, C. So this is the transfer function of the given signal flow graph. Just here I wrote the complete analysis. As per procedure, just follow this standard step-by-step analysis. First of all, we have to write the Masson's gain formula. Later, find out the number of forward paths. Based on the number of forward paths, write the transfer function formula of this signal flow graph. Later, find out first forward path gain, second forward path gain based on the number of forward paths. Later, find out the individual loops. Then two non-touching loop pairs. Then three non-touching loop pairs. Later, find out the delta 1, delta 2, and substitute all this within this formula. You will get the complete transfer function of the signal flow graph. Just here I have explained one example. So this complete analysis I want to explain with a simple shortcut technique. Simple shortcut technique means no need to write all this. Directly we have to write the transfer function based on the given signal flow graph. Now here I am going to explain how to write the transfer function from the signal flow graph directly. That purpose, first of all, we have to identify the number of forward paths. So this loop has one more path also, right? I'm taking the previous problem now. Okay. So first of all, identify the number of forward paths. So just draw the dotted lines of that forward path. This one is comes under first forward path, and it is comes under second forward path. So finally, it has two forward paths. Then write the transfer function formula directly like this. These type of techniques you have to apply for the competitive exams, because in competitive exams directly we have to write the transfer function without using the step-by-step analysis. So within the given time you have to solve this type of problems. That's why I'm explaining this procedure here, right? So first path and second path, two forward paths are there. So based on the Mason's gain formula, it has P1, just write like this, P1 delta 1 plus P2 and delta 2 by delta. This we required. So P1 delta 1 plus P2 delta 2 by delta. So based on the number of forward paths, write one bracket representation like this. And whatever the gains directly write within this equation only. Now I am going to write here P1, first forward path gain. See, 1 into 1 into 1 into 1. So it gives me 1. And later P2, write this one. P2 is second forward path gain. 1 into D into 1. Write directly here D. And don't write delta 1, delta 2. Delta 1, delta 2, you have to write after writing the delta. Later I want to write the delta. So 1 minus. Delta formula explains 1 minus sum of all individual loop gains. So just go through this one. Here it has loop 1. So what is the gain there? Minus A, write that one. And here it has the loop 2, the complete closed path. From the signal flow graph, just identify that. No need to draw the loops separately here. So this is a loop 2, this is minus B, and here loop 3 is there, so minus 3. Write individual loop gains first. Plus, write directly two non-touching loop pair gains. See, L1 loop and L2. Just for further purpose, you have to compare two loops at a time. Now I want to compare L1 and L2. L1 and L2 does not have any common node. That's why I'm taking this is one pair, two non-touching loop pair. Minus A into minus B, AB. And L1 and L3 does not have any common node. Then write the product of these two, AC. And L2 and L3, common node is not there. So L2 and L3 are also acts as a two non-touching loop pairs. Then write a BC. Plus, later you have to write, minus, right? This one is plus, and here you have to write minus. Minus three non-touching loop pairs. At a time we have to compare three loops. L1, L2, L3. These three loops does not have any common node. So this is comes under three non-touching loop pairs. So write the product of the individual gains. So minus A into minus B into minus C, then which becomes a minus ABC, right, like this. And later go through the delta 1. Delta 1 formula explains 1 minus sum of individual loop gains of non-touching loops of that forward path. Individual non-touching loop gains of the first forward path. So the first forward path is this one. This signal flow graph has the three loops. So all loops are touching. That's why we can write here 1 minus 0. 1 minus 0 is a 1 only. And later go to this one. Delta 2. 1 minus non-touching loops of the second forward path. So second forward path is defined within this direction. And this L2 is non-touching to for this. That's why I'm writing here minus B. So finally I wrote the complete transfer function of the signal flow graph in single step, right? So this type of analysis we have to use for the competitive exams, and especially to solve multiple choice questions we have to apply this type of techniques. But semester exam point of view, you have to follow this standard procedure, step by step analysis. In this video just I have explained how to find out the transfer function from the given signal flow graph.